in section 5.1 on Friday, we revisited things that we already knew about polynomials, how to simplify them, how to classify them, the degree. We also found that the degree tells us what? What's one of the things the degree tells us? If the left-hand side does the same as the right or the opposite, if it goes up or down. What's something else we learned? How to classify it. It also tells us the number of turning points has to be less than the degree, or the number of x-intercepts. So today we're going to combine all of that. And what we're going to do, we're going to find the zeros of the polynomial. Now zeros, if they're real, are x-intercepts. But they can also be, what if they're not real? What do we call them? Imaginary or complex. So we're going to find the zeros of this polynomial. How many should there be? There should be 3. So we're going to work that out and see if we can find 3 zeros. Anytime we're solving a polynomial, the first step is going to be to try to factor it. What's the first step in factoring? Greatest common factor, which in this case is x. So we are going to factor out a greatest common factor of x. We can't because they're not like an x to the third, an x to the squared, and a linear x aren't considered like terms. All right, so then we're going to factor out an x from each of these, and that gives us x squared minus x minus 12. And let's see if we can factor what's left in parentheses. It's a quadratic, so we look and see there's nothing in front of the x squared. Is there something that multiplies to negative 12 that adds to negative 1? Negative 4 and positive 3. So we're going to have x minus 3. Wait, y'all said negative 4 and positive 3. So x minus 4 and x plus 3, and don't forget that original x that we took out. So we factored. How do we end up finding the zeros? Do you remember? Set each factor equal to 0. And solve for x. So we have x equals 0, x plus 3 equals 0, x minus 4 equals 0, which gives us 0, negative 3, positive 4. How many zeros did we say we were going to have? 3, because of the degree. And how many did we have? 3. 0 is a 0. Okay? 0 just means if I plug it in for x, it's going to be equal to 0. It also means the x-intercept of the graph. All right, so here's our second example fully worked out for those of you tuning in on YouTube. All right, what are the zeros of y equals x minus 3 times x plus 4 times x minus 1? Then it tells us to graph the function. All right, what are the zeros of this function? Who can tell me just by looking? Raise your hand. Lexus.
What is it, x plus 4? Not x plus 4, x plus 3.
Okay, so a positive 3.
A negative 4 and a positive 1.
Good. If you set this equal to 0, you get positive 3. If you set this equal to 0, you get negative 4. And if you set this equal to 0, you get 1. So we're told to graph the function. We're going to use everything we know at this point. Oh, well, guess that's where I'm going to stop. Okay, so draw your little graph. I need to pause this while I do all this. All right, so So we've determined that for this problem, our leading term is going to be x to the third because we'll have x times x times x. Now, zeros. What's another word for zeros if they're real? X-intercept. So to graph those, we're going to graph at 3, -4, and +1, an x-intercept. Mm-hmm. 3, -4, 1. I can also graph my end behavior. If my leading term is positive x to the third, what does that tell me about the right-hand side of the graph? Does it go up or down? It goes up. So this one's going to end up going up. And because the degree is odd, what's the left-hand side going to do? It's going to do the opposite. It's going to go down. Now, we know, you don't have to write this part, but we know that all cubic graphs look something like this. Or they might go like this. But they might also have much bigger dips. Or they might have no dip at all, hardly. Cubic functions can take on similar shapes, but have different variations. So what we're trying to do is say, well, I know it's going to have a hump here and then a hump going down there. All right? We know there's going to be a max here and a min here, but is the max like way up here and then comes down, or does it just kind of come like this? That's what we have to decide. So in order to do that, we're going to make a table of x values in between our zeros. Make a table with x values in between the zeros, or the x-intercepts. You don't, sorry. Okay, so our values that are in between the x-intercepts going to be -3, -2, -1, 0, and then 2. Okay, so we're going in between the x-intercepts. In between the x-intercepts. So I'm going to use -3, -2, -1, 0, and 2. Now this is about the most I've ever had, picking x values in between the x-intercepts. Most of our other practice problems, the x-intercepts will be closer, so you won't have as many points in between. But then, once you get it, that's what you're plugging in for x in the given equation. So that's going to be -3 minus 3 times -3 plus 4 times -3 minus 1. Minus, plus, minus. And so, when you work that out, you end up with 24. So the first point you would plot would be -3, 24. Well, y'all, that's way off my chart already. Okay, there's 22, 24. I'm probably going to go off the page. I told you before we started, I knew we were going to be pretty tall. All right, then plug in -2. And see what you get. And you get 30. I mean, seriously. All right, go ahead and fill in your chart. I'm going to pause the recording while we fill in our chart. No, I'm not. I'm just going to finish. Y'all okay? All right. So when you fill in your table, that gives you some more ordered pairs to kind of give you an idea of what our graph looks like. Now, we don't know if 30 is the highest it goes. There might be some fraction like -2.5 that goes higher or -1.5 that goes higher, but it gives us a somewhat accurate, better than just guessing, sketch of the graph when you combine it. So, reviewing what we did, we found the zeros, which are x-intercepts. We plotted points in between. We found x values in between the x-intercepts, found their y values, and plotted those points and connected them. And then we used our leading term to determine the end behavior. What questions do you have? Okay, so for those of you that have neglected watching the video, here's our latest problem. We're trying to write a cubic polynomial with zeros at 1, -2, and 4. So we wrote it in factored form. The 1 comes from a factor of x minus 1. The -2 comes from a factor of x plus 2. The x minus 4 was where we got our 0 of 4. So we multiplied the last two together. We can't multiply all three at a time. So we multiplied the last two together and got this. And now we're going to multiply it by that first term. Okay? Jacob, if you need to go, you can go. Yeah. Okay. Thank you. All right. Anytime you want to come back, you're welcome. All right. Now we're going to distribute that x. Okay? We're going to distribute that x. And get x to the third minus 2x squared minus 8x. You're going to distribute the x first to x squared minus 2x and -8. All that does is bump everything up an x. And then you're going to distribute the -1. So -1x squared plus 2x plus 8. And that's going to give you y equals x cubed. Put your x squared terms together. Then you've got a 2x. And what happens with the oh wait, there was a minus 8x there. So minus 8x plus 2x is minus 6x. And this is what you get. That is a cubic polynomial in standard form. Where?
Before the -3.
That's x squared. X squared minus 3x squared. Oh! Hey, Daphne caught another mistake. This is, it looked like a 2, and I even thought it was a 2 myself. It's a 3.
I just changed it for you.
I'm sorry! Y'all are probably the reason I gained weight in the first place. Okay?
You still look the same. You good? You still good, Mom? What you be saying?
Alright, so let's review. Let's review.
Oh, I didn't write it down.
These were the zeros we were given. So 1 comes from the factor x minus 1, -2 comes from the factor x plus 2, Positive 4 comes from the factor x minus 4. We cannot multiply them all together at once, so we're going to take it in bits and pieces. We're going to start out by multiplying 2 at a time, because we know how to do that. We FOIL, and we get x squared minus 2x minus 8. We just bring down that x minus 1, and we distribute it one piece at a time. We distribute the x to all 3, and then we distribute the negative 1 to all 3 and combine like terms. Y'all think y'all can do that if you look back at your notes?
No.
You're fixing to get a chance after this next example.
Oh, no.
All right, last example. Guys, this is the end. And then I'm going to give you 20 minutes to work on an assignment.
And then do it Friday once we don't do it Friday.
Pretty much, yeah.
I better have 2 stutter bucks. First, you never do homework. I have things to do.
Find the zeros. What does it mean to find the zeros?
Find out how they know numbers.
It basically means solve. And one of the ways that you can do that is by factoring. All right, how do we start factoring? We take out the greatest common factor. Take out the greatest common factor, which is x.
What is that last number for? Why does it say f of x? Does it always say f of x?
Yes. F of x is just another way of saying y equals.
Is that 2 on top of the 4? Yeah.
Yes, this is x to the third minus 4x squared plus 4x. Then we factored out a GCF of x to get x squared minus 4x plus 4. Now what do we do when we have this? We need to factor. What multiplies to positive 4 that adds to negative 4? Negative 4, negative 1 multiply to positive 4, but they add to negative 5. Negative 2, negative 2. So this will be x minus 2, x minus 2. Now we're told to find the zeros. So we have to set each factor equal to 0. Is there any sense in writing x minus 2 twice? No, it's going to give us the same number. So we have x equals 0, x equals 2. We call 2 a multiple 0. And we're going to study that later in this chapter, not for this first test for chapter 5, but on the second chapter 5 test. If we did do the x minus 2 again, we would just get 2. So what we say is that the zeros of this function are 0 and 2. But we say that 2 has multiplicity 2. And what that means is it occurs twice. So on your homework, there's going to be a question that asks about multiplicity. It's going to say find the zeros and tell their multiplicities. Well, if you don't understand that, it's okay. We can go over it tomorrow because I kind of rushed it at the end here. But still, find the zeros. And if something happens 2 times, then you're going to put multiplicity 2. If it happens 3 times, you're going to put multiplicity 3. If it only happens once, you don't have to put multiplicity 1. So these are the problems that you're going to do for homework. Not all of these. These are the ones that are in the box. Page 293. I want you to do 1 through 5. 16 is the only one that you have to graph. Be like that when we did in class. Take all 5, make that 1 through 4. Okay. And then, because that has multiplicity, number 5 has multiplicity. Now, 29 through 32. They say find the zeros. 29 through 32 tells you to find the zeros. So basically, guys, all I did was take 2 problems off of this. Not 2, but 1 through 4. Took 8 problems off. But I want you to try to write those in factored form. And I'm sorry, but I do need to add one more to it. Number 12. So throw in number 12. This is quite a mess. I need to write just a brand new one, don't I? Okay, yeah, because it's a big fat mess. So I need you to do page 293, 1 through 4, 12, 16, 24, and 29 through 32. You've got 20 minutes to start it right now. 20 minutes to start it right now. I want you to use that time wisely. Okay? Use that time wisely. Don't waste it. Do those problems right there. Yes, Kelvin. Do we not have an extra one in here?